start. Okay, right, so that's now recording. What I'll do, if you just tell me when you can see my screen, Maru. We'll get started.
Yeah, I can see your screen, Steve. Yeah.
Okay, so you should be able to see, I'll go on to full screen. So you should be able to see the future of buildings, healthy buildings, and my name. Okay. So if anything fails, let me know, Maru, as we go through. So quick introduction of myself. So my name's Steve Rainbow. I work for Trend, who've been owned by Honeywell for 15 years or so now. I work as a key account manager predominantly. So my role is to look after particular end user accounts, certain ones that I'll make reference to without the names on this presentation tonight. So my role is to make sure that the end users obviously get what they want. I write specifications for new builds, things like that. But last July I was actually on annual leave and came back to the fact that I'd been asked or put forward to represent the business as the UK ambassador for healthy buildings. So as you can imagine, that was a minefield of information, hundreds and hundreds of slides, lots and lots of research to look through. But after a couple of months, I hopefully made sense out of it, and hence what I will be presenting tonight to you is really my findings. What I'm looking for now is the move forward. So the actual presentation itself, we're going to look at what is a healthy building, what needs to change and why. So why has all this come about? The main criteria that I want to look at, and obviously I'd like some feedback from you at the end of this, is this enhanced indoor air quality that I'll spend quite a bit of time on. There'll be then just some closing notes and a last future looking slides to finish off with, followed by Q&A. I say please, fire questions to me at the end, pop them in the chat box as we go along, and we'll see what comes through. I have found that this subject actually raises as many questions as I can answer. I'll emphasise at this point, I am not in any way, shape or form an air composition or air quality expert. We'll leave that to the people that concentrate on that. I'm a controls engineer. There's a lot of science gone into what I'm going to present tonight that I've actually got quite passionate about and quite excited about. So I'm hoping you'll feel the same. So yeah, so please save your questions or post your questions as we go along, and we'll try and answer them at the end. So what is a healthy building? So I'd still be apprehensive myself on going on public transport unless I knew exactly what I was getting into. And I doubt whether I would. There's obviously been a lot of restrictions over the last year. So what we're trying to do, certainly in the bigger cities, certainly in London, where we have a lot of real estate, they'll be looking, to reoccupy those buildings over the next 2 or 3 months. They'll be looking to get people back into those spaces. And what we need to do is ensure that the spaces they're going back into and reoccupying are as safe and as clean as possible, based around industry guidance that, again, I shall run through in a few minutes. But it's more of this reassurance. It's, can we, reassure people that the environment, the building they're going back into, is as clean and as safe as possible. As a lot of us been working from home, I, for one, have been in these within these four walls for a year, and it's certainly, far away against the norm. And there's a lot of research been done recently about getting people back, and they're saying that 51% of workers are fearing getting sick from being back at work. So what we're trying to do is work out how we can protect them moving forward. How can we, make sure these spaces are as safe and as clean as possible. We've all got used to mask wearing, to social distancing, to all the things we've associated with this dreadful pandemic. What we need to look at now is the way forward, the way, moving away from the pandemic. I think a lot of this now will be based around well-being. There will be a new normal. And I think that normal needs to be a safer, cleaner environment for people to operate in. So the main issue is the environment clean, safe and ready for business. Are the employees, students, visitors, customers comfortable at coming back? I say we found that a lot of people aren't. They're still quite nervous about going back into buildings, certainly where there's large groups of people. And time-wise, how quickly can we implement the changes? Well, to be honest, when we looked at this, everywhere was in furlough. I think October was the first real push. Yeah, if we could have had, things in place by October, it would have worked. We've got solutions in place now. They're being delivered globally. They are being delivered certainly within the UK. We've got a lot of interest in these solutions now. So this is ready to go. So again, if anybody, knows of anything or knows of any clients that need any advice and how we can get this implemented, then please get in touch. So the actual initiative, as far as Honeywell as a company are concerned, splits into two. I'll not be talking about the safety and security aspect today. This is just really relates to people counting, temperature screening, frictionless access control, built around the access and security systems. If anybody wants to know any more about that, I will certainly, put you in touch with the people that can advise you. The important piece to me really is all around this improved air quality and this, what we're calling IAC sensors, the indoor air quality sensing devices that we've really not done much on before. I want to talk about dashboards, how we can relay information and data that we can gain from a building and gather from a building to make it useful, worthwhile projecting that over to either the building occupiers or the facilities managers within a building. Where is this applicable? We started off middle of last year, really looking at the healthcare. And in theory, the healthcare should have had the cleanest environments possible. We've found out since they probably haven't. There's a lot of health acquired infections that people get from hospitals. So there's a lot more research going on with one of my colleagues who looks after the healthcare world. But what it then triggered was that basically anywhere where we have a BEM system, anywhere where we have gatherings of people, to be honest, we can implement the changes that we're being told we need to implement. Airports are going to start having a massive, influx of people going away again, hopefully. Office buildings are massive in our industry. We have a lot of commercial buildings, schools, universities, colleges, factories, anywhere where people are gathering, we can implement the solutions that I'm going to talk about tonight. So if we looked at the whole coverage, the whole end-to-end solution, the red areas here relate to the access, security, temperature screening piece. It's the orange pieces that I want to talk about this evening. So IAC sensors, these are new. These are something that we've never really concentrated on too much, and it's this that I'm going to be talking about in quite a bit of detail. And we're calling it enhanced air quality. So basically, if we can now measure the composition of the air in any area within a building, even if we implemented local air purification or local UV sterilisation systems, or even if we just opened a window, if we can sense what's happening to a finer degree than we ever have done, and then relay that information back into our supervisor software, we can start to do some useful analytics and useful, information sharing with our system that already exists. We could then relay data from the head end, from the facility manager's department, possibly to a dashboard at the entrance, or even just a traffic light system, so that people entering the building will be able to see that the air quality met guidance, was well within that guidance, and it would give them some kind of reassurance that where they're coming back into is as safe and as clean as possible. So why did we got involved? Where's this all coming from? So I've left these dates in here because this is the 3rd of April. Revar have issued a new one. I think on April the 15th is their latest release of information regarding building usage. I have a client that couldn't shut the buildings down. They had to be manned 24/7. And they came on to me and said, Steve, what do we do? Because we're being told we now need to run the ventilation systems, basically flat out. We need to be introducing as much outside air as possible. So we need to get rid of the recirculation modes on the air handling units. We need to be running plant for longer. We need to be running toilet ventilation 24/7. And we need to be exhausted as much air as possible. I'll go into the obvious pitfalls that you've probably already gathered from doing that in a few minutes' time. But basically, this came from Europe. ASHRAE, yourselves, you guys on the call, we work very, very closely in the States with ASHRAE. ASHRAE emphasised exactly the same point. We need outdoor air ventilation. We need to remove or get rid of recirculated air as much as possible. They then start talking about introducing greater filtration, a MERV 13 or above, run the plant for longer, introduce portable air cleaning devices and UVGI devices. The temperature and humidity we've found is to be okay, so we're quite happy with the temperature and humidity set points. Again, I'll explain a little bit more about that later on. And then at the beginning of all of this, they were talking of bypassing energy recovery vent. So a thermal wheel sits in the ductwork. It's slowly turning round, or it'll go at a speed relative to the amount of heat or cooling we want to reclaim from the return air. If that return air is contaminated and goes through that wheel, 180 degrees later, there's a chance we could be blowing that air back into the space. What they're saying now is that we can actually run those wheels and we can run them faster, but we're losing out on the actual heat reclaim that we can get for them. So what I will emphasize is all this is guidance. There's nothing saying if this is what will be done. This is all based on research, and it's all based on the ideal. Where do we really want to go? SIBSI. Obviously, we're all aware of SIBSI in the UK. SIBSI advise Revar. Okay, they saying the same. So increase supply and exhaust ventilation, supplying as much outside air as reasonably possible. Bear the word reasonably in mind, because in the Northern Hemisphere, if it's -10 outside, the plant won't be designed to run at 100% fresh air. And what we will then be doing is we'll be hitting the wrong KPI, the 16-degree temperature, limit will come into play. We're going to have to recirculate the air. The systems haven't been designed. Again, there's lots of research been done on Northern Hemisphere systems and how they won't be able to cope. Fortunately, we didn't have a very severe winter. And fortunately, we didn't have a very hot summer last year. There were just a couple of instances where I had calls saying that the cooling systems couldn't cope because the outside temperature was high. Again, the cooling systems won't be designed to run at 100% fresh air. The reasoning behind all this at the time, if we talk about COVID, was the fact that the larger droplets that we expel when we cough or sneeze or even talk will fall to the floor before 2 meters. But however, there's very, very fine aerosols that remain in the air and can remain in the air for several hours. And it's the transportation of these aerosols that a lot of research has been done on. I did about a 6-hour training course with Revar, really complicated, on how quickly the moisture surrounding the particles evaporated. Real different science to the world I'm into. I say I'm not an air composition expert, but at the end of the day, these aerosols are in the air, hence the reason to say we need to exhaust them. If they're returning up the return air ductwork, we need to be removing them from the building. This then would relate to a risk assessment. So we've been doing risk assessments as a company for several clients. Everybody has done a risk assessment regarding PPE wearing, the amount of occupants going into a building. Before they open, they will be doing a lot of work. Way back last August, there was one of the main guys from SIBS on the BBC News. It's the first time I'd actually seen an air handling unit on News at 10, which was quite sad, because he was saying we really need to look at the air that we're bringing into these buildings. We need to look at the ventilation systems. So this risk assessment is key. We can help, and obviously chartered engineers can help if we need to make any changes to ductwork. I'm really just emphasising here that this is a global initiative. This isn't something that we've jumped on the bandwagon of because of COVID. This is something that really is high on everyone's agenda. So we've mentioned European, we've mentioned America with ASHRAE, we've mentioned SIBSI. This is ASHRAE, and ASHRAE said exactly the same. Increase the fresh air intake, MERV 13 or above, UVGI, and a combination of those is going to make these places safer and cleaner. Okay. Now, what's also come to light is the same fresh air. If you Google air quality, you will find prior to COVID, or prior to I think probably up to 4 years ago, there's loads and loads of research being done on outside air. So there's lots of research, reducing vehicles, vehicle emissions, wind turbines. We're now being told by all of these authorities in the world that we need to bring as much outside air into these buildings as possible. How do we know what we're bringing in? They've been wearing masks in Tokyo for 15, 20 years because they know the outside air is so polluted. Yet the only way to introduce fresh air to a building is to bring outside air in. So like I say, this has really raised lots of questions, and this is where we're moving forward, move away from the actual COVID piece. Let's look where we're going to go with air quality in the future. So how do we improve indoor air quality? We know we can start changing strategy within a control system that gives us a better exchange rate. CO2 is still the key property within the composition of the air that we need to be measuring. CO2 has always been the one that is key. There's just more we can add to that. The temperatures, we know the temperatures are okay. The right temperatures improve health and well-being. Now, if we're sitting at 21 degrees, the ideal temperature, it's been proven that people are more productive. It's a healthier place to work. Same with humidity. Research has proven that between 40 and 60% RH, there's less chance of infection. We can add air cleaners. We can either add cleaning devices in the ductwork, we can add it within the rooms, but we can then start to remove particles that we've probably not removed before, and we can make the air cleaner. We can introduce UV sterilisation, whether that be in a package unit or a duct-mounted lighting system that cleans the surfaces of the air handling unit to remove any more bacteria from the return air or from the mixed air. Yeah. Pressure control is something else that we can do using Venturi valves. So this is more related to clean rooms, operating theatres, laboratories where we need positive pressure. So all of these are all areas that we can look at and improve to make the indoor air quality better. So we're trying to make places more desirable, better places to work, healthier, cleaner places. And it's about this reassurance, moving back into these massive offices in London. I read this morning that they are converting some offices now into flats because of the reluctance of people going back into them. So if people are going to back in, we need to make sure that the places are safer. We need to know it's safer, which is something we can now do, and we need to keep it safer. So we can start to look at different methods of making sure that what we have is cleaner and safer. So that was the why, that was the reasoning why behind, that's the research that's been going on. So now we're looking then at how we can act. What are we doing around this enhanced indoor air quality? We know that better indoor air quality is better for the people in there. Why have we never done anything on it before? Because we have air quality sensors, we have duct and space sensors. I can't ever remember a project that I've been involved with where we use them. So if we looked at the air quality composition in a real basic way, temperature in a BEM system, we always look at temperature. We always have done. We'll set limits, high limits, low limits based on temperatures going out of the parameters that we set in the system. A few years ago, maybe not so much now, we used to do a lot of humidity control and a lot of dehumidification strategy within air handling plant. There are always issues of bottles furring up, as I remember. We still have that within specific areas, museums, libraries, laboratories, pharmaceutical industry where we make manufacturing powders or tablets. We need to have strict humidification, dehumidification strategies. And then CO2. So this is a key element. Probably 20 years ago was the first time I did a project in a school where we asked to put CO2 sensing devices within the classrooms. The sensors were wired back to a controller. We literally had a light that sat next to the light switch. So we had a double ganged light switch. So if the CO2 went above a certain limit, the light would come on. The teacher would then manually open the window to introduce more fresh air. And lo and behold, we got our very first indoor air quality control system that was manually intervened by the teacher opening the window, but it stopped the kids nodding off while they were being taught. So those three elements, we know a lot about them. We've always been fitting them. Yeah, they are the norm. What we've never really worked or concentrated on before, what we call these volatile organic compounds. Again, if you Google it now, these are the buzzwords of the moment. So the VOCs, the particles within the air. Imagine when we're switching an overhead projector on in a dark room, all of a sudden the light that was shining towards the screen is full of, these particles that we can't see normally. Within those, there's even particles that are tiny, even smaller particles. So we need to understand what these are, at least be able to measure them. We've never really measured them. Viruses we can't measure, but we can probably understand how they move. Okay, so if we could introduce filtration to remove as much of this as possible and monitor what's been removed, the chances are we're going to reduce these. And if we introduce disinfectant solutions, UV lighting solutions with a proven capability, I say again, we're not saying we're going to kill COVID or any other virus or bacteria. We are definitely going to make it better though. It will be safer, it will be cleaner. So there are solutions, there are ways of doing this moving forward that we've never looked at before. So if we put this in a little bit more perspective, this is your SIBSI statement of your coughing and sneezing and the larger particles falling to the earth within your 2 meters or still feet in America. It's these very, very tiny particles that remain in the air. Now, there is a chance that these are actually hitching a ride on these other compounds and these other very, very tiny bits of material that are sitting within the air. Okay, these VOCs, these can be fumes, they can be, gases, very, very minute compounds within the air. To put that into perspective, if that's a human hair, that would be PM10. That would be a typical filter on an air handling unit. That's how far we would go down. The pink elements in there is PM2.5, which are even smaller elements, smaller particles in the air. Favourite slide coming now is that one. PM10, that's pollen. Okay, we can't see that. We could see it, there's a lot of it, but we can't see pollen with a naked eye. So we can't see PM10. So there's no way we'll be able to see PM2.5. Yet if we start to look at viruses and bacteria, you can understand why it would be very easy for these to hitch a ride around a building on one of these particles and use it as a carrier. Hence the reason to either filter it out or dump it. Let's get rid of it. Let's get rid of that return air and get rid of anything that could be contaminated. So if we filter to that point, then we introduce UV sterilisation after. We're doing our damnedest to remove as much of this as possible and hopefully a lot of this at the same time. Bring that into my world of plant and air handling units. So this is an air handling unit. In this instance, this really relates to a customer I was working with in London. So they've been asked to implement the strategy changes, to implement the no recirculation, plant running flat out. All of their air handling units are fixed 80% recirc. They haven't got a mixing box. They cannot meet the requirements, so they've introduced filters, UV sterilisation on the supply. They've also now put it on the return air. So they are now looking at outside air coming in, cleaning it, sterilising the unit, sterilising the cores within the air handling unit, delivering that air into the space, and then bringing it back through the return and again filtering it and sterilising it. Now what they're also doing is they're monitoring. So they're measuring the outside air, they're measuring supply air, they're measuring return air. I mentioned earlier on that we've got sensors typical within a BEM system, temperature, humidity, CO2. These are the norm. These will be installed in most systems. We can retrofit those. We've now introduced a range of PM2.5 sensors, so space sensors and duct sensors and TVOC sensors. Now these are analog, so they work on a 0 to 10 volt signal. The same really as these what we call active sensors. So CO2 would be 0 to 10, 4 to 20 milliamp, humidity the same. Where we're seeing a big take up at the moment is with these devices here. And these are all in one devices. So these units, they will communicate via Modbus. That's the same unit. We're just showing you that there's a traffic light indicator built into these sensors. So we can disable those if you don't want them showing, or they will be set against guidance against limits to light. So we have a traffic light system within rooms, within classrooms, within lecture theatres, within lobbies, where we can immediately see what the air quality is like. Is it within guidance? Does it meet the requirements? So these are the ones that are getting the most interest. That's the duct sensor. And that, again, the very, very clever Modbus communication, hundreds of different parameters that we can measure. These are like controllers in their own right. So they won't only just tell us instantaneous values, they will log and tell us what the last 24 hours have been like, you know, the last week. Very, very clever little devices. So if we've now got these sensors mounted within the ductwork, and this is the middle of London on a Monday morning, and we're running this plant, if this had got a mixing box on it, the chances are at 8:30 in the morning, the outdoor air could be more contaminated than the air that we've just filtered and UV sterilised twice. So there may be a chance that we could introduce recirculated air now back into this space, because the air, because we're measuring a lot of the main contaminants within the air, we can actually start to research, make this plant more efficient. So again, like I say, it's raised lots of questions over carbon monoxide sensing. We've got to have, why haven't we got carbon monoxide in your fresh air duct? NOx sensing, you know, this is the same as you have on your exhaust pipe. surely we're not doing enough around this air that we're bringing into these spaces. Even if we had local UV sterilisation within the space, obviously no one would be in the space while this was running, or local filtration, or like I said, we open a window, because we can now measure what these elements are, we can do a lot more than we used to be able to do, certainly on informing the occupants as to the cleanliness of the air. Okay. Filtration wise, I will talk about it. This would be your typical PM10 panel filter. Okay, so this is removing your pollen, your larger particles, typical within an air handling unit, which would probably maybe followed by a secondary filter that may go down to PM5. We have panel and bag filters. Obviously, operating theatres, very clean areas have HEPA filters. Very difficult to retrofit a HEPA filter because they have a massive pressure drop across that unit. Very expensive. The system will be designed against the pressure drop that will create. So very difficult to actually retrofit something like a HEPA filter. However, we could introduce an electronic air cleaning device. Pressure drop across that 60 pascals. So in theory, that would be less than that. So we could actually start running the plant more efficiently if we introduced electronic air cleaning, and we're now working to MERV 14, and we're removing 95 to 99% of the PM 2.5 particles. If we then introduce UV tubes after this device, we're doing exactly what they said in ASHRAE and ASHRAE and everywhere else, is we are doing our best to remove as much of this, virus and bacteria as possible, or just to clean the air, something we've never really done before. And we can now measure the component parts to prove that this has actually done what we've said it'd do. If we start to introduce anything more, this HEPA filter, for example, into the duct, we will start to get changes in flow rates. So obviously it was not going to hit design at that point in time. That's when we would need an engineer to get involved to say, we need to be doing something else. This has to be probably the easiest solution moving forward. So how does it work? It works on ionisation. Don't know if anyone's looked into this. This is the problem with doing it this way, it produces ozone, and if we actually do this process to the whole of the air, the ozone that's produced in doing it is massive, way beyond the allowed levels, whereas any ozone produced within this unit is retained within the unit. But all we're doing is we're positively charging the particles coming in. We have negatively charged collector plates within the unit that actually attract the positively charged particles so that the air coming out is cleaner. UVC has been used for years and years for removing bacteria from air. A lot of these units used to be mounted on ceilings, not directly shining onto people, but used to clean air at high level. And a combination of these units is going to look at killing 99.9% of bacteria. So like a Domestos advert. But basically, that is the theory behind it. This is something that we've got specialists in. Again, I wouldn't personally be recommending to anybody, the size of one of these units or the size of one of the UV lamps. The UV lamps are sized against a flow rate, against a meter cubed rate. So, someone would say if you have a duct that's a meter squared with a flow rate of 4 meters cubed a second, you need a dual lamp or a triple lamp, whatever it may be. And the science behind it will be on the data sheet to say this unit will achieve what we're telling you it will do at that flow rate. It is a different science, but at the end of the day, these are the solutions that we have available. A lot of them can be retrofitted directly into air handling units as we speak, and they are being done as well. So a quick summary, air quality summary. So this we talked about libraries and we talked about museums where we may have humidity, certainly CO2 sensing, temperature sensing, occupancy. We could get occupancy from a directly connected sensor to the BEM system. We could pick occupancy up from the lighting system. We could even pick the occupancy up from a room booking system if it was needed. So that would give us, in a, ideally, a normal indoor air quality controlled space, which would be considered to be, industry normal, as we'd expect. If we go for this enhanced air quality solution, this is where we've installed one of these multi-sensors within a room. So whether that be a boardroom or it be a lecture theatre or a common room, it doesn't matter whether we have main plant feed in this room. If we know what the air composition is, we can react, we can do things with it. So even if we've got a local air purification device, local UV sterilisation, obviously, again, that wouldn't be running with these people sitting here, or they've come out with a good suntan. But obviously what we can do is, because we can monitor that, we can make, decisions against that space. A few months ago, I went to the dentist for the first time in a long time, and they had within the room a unit. I think it was a Mitsubishi packaged HEPA filter unit with UV sterilisation in it that was sat next to the dentist's desk. And when I'd finished having my inspection, we got onto the subject of enhanced air quality, as you do. And I said, what do you do? What's that for? And he said, basically, it cleans the air and it sterilises the air before the next patient comes in. So I said, how long do you run it for? So he said, 15 minutes. I said, why do you run it 15 minutes? He said, well, that's what they told us we need to run it at for a room of this size to achieve what it needs to achieve. So I said, yeah, but you don't know, do you? I said, but if you could monitor what was happening, what had that done? You may find you only needed to run it for 10 minutes. You could see more patients in a day, or you may find you actually need to run it for 20 minutes because you're putting at risk, the patients that are coming in. The room isn't quite as clean as you thought it was. So that was just an analogy of me seeing this a few months ago. Even if I say we opened a window, it will have an effect on that. If you look at the guidance relating to social distancing, the wearing of PPE, the government are saying bring more fresh air into your buildings, open your windows. It's the fact that we've never ever monitored this before. So the more we can monitor, the more we can put into what we call in the Healthy Building Dashboard. So that first instance on the last slide, we've got temperature, humidity, CO2. We've done these strategy changes because the guidance telling us that we need to. ASHRAE, CIBSE, these guidance, they're saying we need to be doing more air changes. We need to increase the percentage of outside air. A lot of these have been implemented already, certainly on the buildings that have been occupied during lockdown. We've been involved with a lot of the strategy changes. Yeah, so obviously as we move on, if we start to introduce the particle measurement, or we put in the IAC sensors and we started to measure TVOC, we've got more data coming into the BEM system. So we can do more with that data, and we can, display greater accuracy, the quality of that space. I mentioned temperature and humidity. Typically in the UK, we'll sit at 21 degrees C, 50% RH. We've always had limits on temperature sensing devices. If it goes to a high limit or a low limit, we can flag an alarm. Yeah, we can change the colour of an indicator from green to amber to red, the same as I showed you on that air quality sensor. It's been proven that between 40 and 60% RH is less risk of respiratory diseases. So we know now then within the BEMS world that we've got some parameters to work to, as we had with temperature, 21 degrees C, probably 24 degrees C as a high limit, 17 as a low limit maybe. We could do the same now with RH. We know 50% is really good, but within that band it's okay. If we then start to drift below 60, above 60% or below 40%, we can now start to change the colour of indicators, make people aware that we're not within an ideal scenario. We're not in the ideal. That's something that we've done before, temperature and humidity. We've done it with CO2. And part L tells us the level of CO2 that's acceptable within schools or within buildings. What I'm struggling to find is some way moving forward where we have to look at these elements here. Reset have issued this document, and what they're saying is temperature, RH, CO2, we know CO2 because we've already been doing that. We've got those three elements covered. I mentioned carbon monoxide. There's a limit on that as well. Why aren't we looking at carbon monoxide coming into buildings? Yeah, must be the difference between 8:30 on a Monday morning and 2 o'clock on a Sunday afternoon in London must be massive on the amount of carbon monoxide in the air. Let's start measuring it. Let's start putting it into the BEM system. What we've now got, though, relates to our new sensors. We've now got some form of sensibility around TVOC. What does it mean? We now know. What about PM 2.5? What is an acceptable level? And I know that our guys in America are working with ASHRAE directly to come up with these numbers, which will relate to the dashboard that I'll show you in a second. But now all of a sudden we've actually got some science behind what we're doing. We're not just saying it's good, bad, indifferent. And I say, if you actually Google IAC nowadays, there's so much work being done on this. So the dashboard, we have a head end. Our head end is IQ Vision. Very, very technical bit of kit that does all the data crunching. And we can sit in there, a dashboard that looks at all those elements. And then we can relay that information through to mobile devices or to iPads or your mobile phone, whatever, wherever you need that data relayed to, we can do it. It's a little bit blurred, this picture. Now, to me, there's still a little bit of work in progress to do with this. This is the one where we are dealing and we're working with ASHRAE in America. So we're looking at this pollutant level here. Yeah, has to relate to your TVOC and your PM 2.5. We can do CO2 because we know what that limit is and we know what humidity is. We know what temperature is. Space utilization will be your people counting. So we could do that on occupancy or the room booking system. So if we have a boardroom, the correct occupancy is 10 people. If there's 12 in there, obviously that space utilization is wrong and that would score a lower level. It's making sense of these readings that is the difficult bit at the moment. We could look at the whole building and relay to the dashboard or to the television screen at the reception that we've got a 73% average score. People are going to ask, what about the other 27? Yeah, so maybe we do this just as a traffic light. If it's green, it's within guidance. Yeah, if it's amber, is everybody going to run out of the building? Hence, talking to a university, they've said as an FM team, we really do want to know what that is. We wouldn't want to share that data with the students. So long as the students know that we are implementing this, that's good enough for them. So quite a bit of work left in here. If we looked at zone 1, for example, it's got a poor health score. That's based on temperature and humidity. CO2 and pollutants and space utilization levels are fine. What if somebody's opened a window, it's -3 outside and we've just lost some temperature? Yeah, the humidity's gone AWOL because it's snowing as well outside. In theory, that space could actually be safer than this one because the pollutant level's within guidance. Okay, so this is the work. This is where we're looking at the moment. I say we have very, very simple indicators on the sensors themselves, but this has now got the science and the backing behind it. And to me, this is the way forward. It's something we've never ever done before, and I'd have to ask why. Why has it never been done? Kpi dashboard, I just mentioned, we could have a screen. Most reception areas have got a telly. Sit there, smart TV, it's showing the news all day. We could take a piece of that screen and we could put just a graph on it, or a traffic light indicator, or a thumbs up to say it's all good. Or we could have standalone devices. Client decision. Do they want to see that? Do they want to share that data? This again gets us back to this reassuring the people coming into the building that they're coming into a safe area. So this is where we're up to. Pressurization, that's the specialized piece relating to clean rooms, to fume cupboards, operating theatres, things like that. It's something that we've done for years and years. Ventilation, strategy changes more than anything. Temperature, humidity, CO2, readily monitored and controlled. We're now looking at this air composition in a lot more detail than we ever have. And we're now considering greater levels of filtration and UV sterilisation. And this whole wraparound gives us this enhanced air quality solution that we're working on. So where's it going to go? Closing notes, closing slide. Move away from COVID. That's been dreadful. It's been absolutely so bad for everybody concerned. The one thing that it has highlighted is the fact we need to do more of this. And these are just separate extracts, separate snippets of information that we've gathered. Healthy buildings, human-centric buildings, you know, well-being. Well-being, it's all about well standards, well-being, indoor air quality. Why haven't we done it before? Temperature and comfort we've done before. You know, we're now looking at light levels. People are more productive, they're happier with different lighting levels. Air quality again on this one. Air quality, moisture, dusts, you know, this moving forward is the way that it's going to be. I can't understand why we've never done it in the detail that we're now doing it in. I'm hoping that made sense to everybody. You may have seen something similar, I'm not sure. That's the end of my presentation. We've got 10 minutes officially left. I'll open it up for any questions and hopefully give you some answers to it, if that's okay.
Yeah. Thanks very much, Steve, for excellent presentation. Guys, you can unmute your microphone and ask questions. Please go ahead. Yeah, go ahead, Darren. Thank you.
Hi, Steve. Yeah, I'd just like to echo Marie's sentiments. Thanks ever so much. Great presentation, and thank you ever so much for giving up your time to make that presentation for the chapter and members. Yeah, it was very interesting. We're certainly moving into a whole new sort of well, I'll start again, I guess. COVID is changed the way that we work, the way that we think, and even in business and commerce. Businesses, I know, being a business owner, you know, people are thinking differently how they operate as a business. And I did read an article in London actually that they expect there's going to be a huge decline in people actually coming back to some buildings, that the City of London are looking now to convert them into residential properties on that basis. So I think that going back to the number you gave, I think it was 51% people are concerned about getting ill. It's certainly using technology to our advantage, as you've shown. One of the questions that came up in my mind is in terms of going, you know, at the end of lockdown, getting back into these buildings, and you had some touch points on retrofit, and you know, it's great picking some great products, but if you can't, you know, practically retrofit them, it makes things difficult from a timing issue, I'd imagine, you know, sort of a logistics issue. So one of the things I had on sensors, do you see the use of wireless sort of LoRaWAN type sensors being being used. I mean, you mentioned 0 to 10 volt sensors, but that.
Yeah, the ones that are all-in-one sensor is it's LON communications. That would need a power supply, but then the protocol it talks is LON. There's a lot of data that comes out of that sensor. So there will be wireless solutions, I would imagine, moving forward. I've not seen any yet. I've not seen any competition yet who've got a sensor that does all of the elements that we're looking at doing either. I think the elements that we haven't got yet are certainly carbon monoxide. I cannot believe we're not measuring what we're bringing into the buildings. That's got to be key. Certainly if we're implementing changes to plant to clean the air and to sterilise the air. But at this moment in time, they are wired sensors. As and when they become a wireless solution, then all the best. But what I'm finding is that people are tending to do it as a trial. So I have one client that's actually rolling this out. They're putting 102 sensors within the building that's been empty for a year. This is one building, and they've turned around. There's 77 boardrooms, meeting rooms that they want to centre in each room, and then they've got open plan areas that they want to put 3 or 4 in. That to us will be a great case study when it's done. Definitely. You'll find in America they take this a lot more seriously. They will not open shopping malls in America or schools, universities until they've implemented some kind of air quality changes. Okay, so enhanced air, whether they do the full air quality control or whether they just monitor it. So I have 2 other universities now that are looking at monitoring what effect, what's happened. We've introduced this strategy. We've run the fans 100%. We've put it onto full fresh air. What are we doing? What's the actual effect? So I think it will start off as a trial in a lot of instances, and then I think it will really take off as being the norm. There's talk of this being linked in the same way that people, if HSE get hold of it, could this then become the same as Legionella? Because I think we need to know the composition of the air that we're going into. We never have done. And if that happens, then everybody's happy, But if you look at I was surprised how much work's done on outside air and not indoor air. Start talking sick building syndrome. How many people have spoken about sick building? They don't measure air quality, do they? They just bring more fresh air. And what if that fresh air is really polluted? Why aren't we measuring what we're bringing into a building? So this is why I found it quite an interesting subject to get into. I'm not an expert on air quality. All I know is that we've got systems that can now monitor, measure, this new, what we're saying, this new enhanced air quality. But it's the well-being, circadian rhythm, lighting, it's things like that that are going to be key moving forward. I think there's some link between well and BREEAM moving forward. You're probably the guys that can answer those kind of questions. This won't become legislation for a long time, probably, but I do believe it will. I do believe in the future this will become part of the design of a building. Are we going to have summer, winter, pandemic-ready plant? I doubt it, because the way contracting is in the UK, it's done it, as cheap as possible. But in theory, it could have created some major problems this year if we'd had a real hard winter. And I've got 110 buildings running for a customer in London on 100% fresh air. It could have created some major problems. Fortunately, it didn't. They managed to get by putting jumpers and coats on, but it could have been a lot worse. So, yeah. One question that you haven't asked is energy.
I was about to get to that. Yeah. So you beat me to the post there. Yes, exactly that. So it's a double-edged sword, isn't it? As soon as you're looking at indoor air quality, and of course we're trying to make energy efficient buildings, and we've got one customer, a large university on the East Coast, and the problem they've got is, one, they've already got a challenging district heating network to manage. Students coming back, there's no recirculation allowed. It's all fresh air. And of course, the design of the system wasn't designed to take 100% fresh air at those temperatures. And now they're having issues with boilers and boiler failure because they're really running plant to the absolute max. So it's very much a combination of managing both, I guess. But that's it from me, really. But thank you.
Yeah, no, it's been interesting because I've done this that obviously we've had energy managers on the call. In fact, I'm doing it with one of our big partners tomorrow. And there were 3 energy managers on the first session I did with them. And I said, you know, at the end of the day, the guidance is telling you what to do. We can't deny the guidance because that will come from the World Health Authority. You know, that's what people are being told. Everyone's aware we have to run the plant 100% fresh air. The answer is it's health over wealth at this moment in time. But of course, everyone's talking about carbon footprints, and I say it really does raise lots of questions, this subject. And where it will end up, I don't know, but it's certainly going to be, it's got to be included in what we're going to call the new norm, I think, moving forward. Certainly where you've got real estate, so your big real estate companies that rent property in London, they're finding that they've had businesses that are paying £1 million a month for a couple of floors of a building in Paddington. They've been working from home for a year. Lo and behold, those people are quite happy. They're not having to pay any tube costs, travel costs, childminding costs, you know, and the companies are turning around and saying, well, actually, just as profitable, we've just taken £1 million a month off the bottom line. And they're the buildings that, you know, I heard that today. They're looking at converting them into you know, residential accommodation, aren't they, some of the offices? So watch this space. I hope you found it interesting. I'm sure it will raise more questions. You know, I would like some, you know, I'd like feedback. If I can get feedback on the numbers that we're getting from Reset at the moment, it would be nice for those numbers to be coming from ASHRAE. I do know in the States, Honeywell are dealing directly with ASHRAE relating to those numbers, but you know, we've got guidance. We know where we've got to work to. So anyone else? Any further questions?
Charlie, are you looking to ask a question?
No, you and Steve both beat me to the punch because I was going to ask about the energy implications.
The energy piece. There you go.
Yeah.
Okay, they're the usual 2: the energy cost and the fact that plants not designed in the UK. And it isn't just the UK, it is the Northern Hemisphere in general. I think we're really, really bad in the UK for just designing stuff right on the limit, you know, right at just on that limit of possibly might get one day where it's above 28 degrees in a year. We'll let people sweat that day. Yeah, there's no real flexibility. But I say moving forward, you know, summer, winter, pandemic mode, I think it's going to have to be thought about. Unfortunately, this will happen again, and they've got to be ready for it next time.
Is there the concern that if you rush these retrofit systems into place without the kind of comprehensive investigations into the energy implications, that we're going to end up with a lot of buildings that are retrofitted in a much less sustainable design because they rushed to put this in place in the first place?
Possibly, yeah, I would say they will. I think this is why it needs to go in stages, which is good because that's what I'm seeing happen. People are going for the sensors first. The customer where they fitted 101 of these, they're not doing any changes to the plant whatsoever. They are fitting a new BEM system, so it's worked out well. They're upgrading the system, so the timing was perfect. They were going to put just CO2 sensors in. They're now saying we may as well put IAC sensors in and have a greater understanding. They're not doing any changes to the plant, but what they want to understand from the sensors is what do we need to do to the plant. You know,
yeah.
So they're on the Heathrow flight path, let's put it that way, and they're concerned. Yeah, there's some days that they're convinced they're dumping fuel out of these planes before they're coming to land. The fumes are so bad. Let's measure it. Let's see what's there. You know. So.
Thank you very much for your presentation as well.
That's okay. I'll share it with Maru. Maru, if you'd like to share it with everybody. Any questions? Just fire them back through Maru, and I really appreciate. Again, everybody's time this evening, you know, yeah, listening to me babbling on about healthy buildings again. I have found it interesting. I do think it will move forward at quite a rate of knots now it's started. So yeah, thanks for your time. And if you need anything, just ask Maru.
Yeah, thanks very much, Steve. We really appreciate your time.
That's okay.
That was excellent. Yeah. Because
My
at
pleasure.
the moment at Loughborough University is 100% fresh air. It's okay now, but some days it's so cold. students, they're sitting in there with their coats on.
Yeah, but you wait till it goes to, well, it's lovely 30 degrees outside. And your
Yeah.
chiller plant, your chill plant won't be able to cope then. And your
No.
electricity bill is going to be phenomenal because your chillers are going to be running absolutely flat out. So let's have a look. Why can't we recirculate? Even if we manage to recirculate 10%, we're still within the guidance levels on the air quality. Just by reintroduce 10% recirculated air, what's the energy saving going to have? Yeah, because of that. And that's the piece that I'm seeking more guidance from you guys to say, these are the levels. If we can achieve that, yeah, if it doesn't go beyond, if it stays within those limits, and we can go to 40% recirculated air, fantastic.
Yeah.
So, and that's where the research is going. That's what people are doing now. They're putting the sensors in, they're testing it, they're changing, manually moving dampers and looking at the effect of that, seeing what happens. So watch this space. So, okay.
Okay,
Thank you
thanks
so
very
much.
much, Steve. Thank
That's
you.
all right. My
Thanks very
pleasure.
much.
All the best. Cheerio.
Yeah. Thank you. Bye.
Bye-bye.
Thank you, Steve. Thank you.
Okay. No problem.
Thanks, Steve.
Bye-bye.
Bye.
Bye.